In this video, we will be looking at both the questions 6 and 7 of the race number 3 from the Secureum Bootcamp. We're looking at two questions here because we have covered most of these aspects already in previous questions, so it should be quite quick. The first one, number 6, says the function start sale may be successfully called or executed by anyone, may be successfully called or executed with a price of 0, must be called for minting to happen successfully. So if we look at the start sale function, you can see here this require, and the intention for this require is that it can only be called by the deployer, and this deployer is allowed to only set a price that cannot be 0. But currently this is an OR, a logical OR. So currently it is required that either the message sender is the deployer or the price is unequal to 0. So if the price specified when this is called is unequal to 0, anyone can call this. And if the message sender is equal to the deployer, the price can be anything. So the first two options are correct. Now for the last option, can minting only be successful if the start sale function was called? And yes, because it requires public sale to be true. And if we look for public sale, we can see that the only place where it is set to true after being initialized with false, the only place where it is set to true is in the start sale function. So with that, we can say that indeed A, B, and C of question 6 are correct. Now, question 7 says that the minting of NFTs requires an exact amount of ETH to be paid by the buyer. The minting of NFTs refunds excess ETH paid by buyer back to the buyer. So what we send too much is sent back to who sent it. And we have C, which says transfers, that the minting of the NFTs transfers the NFT sale price to the beneficiary address. And it says D, it may be optimized to prevent any 0 ETH transfers in its refund mechanism. So let's take a look at the code of the minting function, and we can see here that we have the sale price, which is determined by calling getPrice, and we can see that the balance of the contract is allowed to be greater than or equal to the sale price. So what the caller sends to the mint function is not required to be exactly equal to the sale price. And we can furthermore see that there is indeed a refund happening here, because we are subtracting the sale price, so what actually needs to be paid, we are subtracting it from the current contract balance. So whatever is the result of the subtraction is basically what has been sent too much or what was already too much on the contract, and this will be sent back to the message sender. So this is indeed a refund. Now a little bit of a problem in this refund function here is that this if seems rather unnecessary, because this if wouldn't have been reached unless this was already true, because this condition is exactly the same condition as above. So this is already required to be this way. So this will always be true. What this should actually be, it should be that balance is larger than sale price, because it only makes sense to refund, to make a transfer, an external call for a refund, if there is actually anything to refund. If the balance is exactly the same to the sale price, it doesn't make sense to make a refund, because the refund would be 0. Therefore, there's indeed a potential for optimizing here. And so let's go through the options. A, it requires an exact amount of ETH to be paid by the buyer. That is incorrect. It can be more. B, the excess ETH paid by the buyer is sent back to the buyer. We haven't looked at C yet. And D says that the refund mechanism may be optimized to prevent any 0 ETH transfers. And we just talked about that. So the last point, C, transfers the NFT sale price to the beneficiary. As you might remember, this was right here in the underscore min function. Here is where the entire balance of the contract is sent to the beneficiary, and after the user, the caller, has been refunded anything that was too much, you would expect that the balance that is being transferred here is exactly equal to the sale price. So I would say that the option is correct because of this, because it should be that. But one could argue that's not true, because we have at least two chances to take over the execution here due to the callbacks. And during this execution, we could just inject more ether value into the contract, and then the balance would actually be larger than the sale price. But why would you do that? Is it intended to happen that way? Not really. And that's why I would say that C is actually also a correct option. And that was questions 6 and 7.